see. Okay, do that one to hold. Just grab a vial. Stick that in my pocket. So this part always takes a little while to get everything set up. This is a pH meter. You have to keep the pH meter in liquid as much as possible, and it's supposed to be stored in a special pH 4 liquid of potassium chloride. So I always bring an extra little container for the storage liquid. And then this is, oh, I forgot to bring the light shield, but that's okay. This one, let me get this off. It's on here so tightly. This is an oxygen sensor, dissolved oxygen sensor, and this is a temperature sensor right here. So I take the pH meter and attach it here. Because it's hard to hold everything with your hands in the river. So all these little sticks and things are so that we can hold all the different things in the river at once. I'm gonna hand that one to you. All right, so what I'm showing here are all the different pieces of equipment we have for measuring different parts of the environment, some different variables, the abiotic variables. So this down here, which I'll show in a minute, is a quadrat. And within the quadrat, we want to measure different variables. So there's this one is for flow. So the propeller spins when the water moves it, and that measures how fast the flow is going. And you want to make sure the propeller is facing upstream. So upstream is this way. So the water would be moving it. You guys can see that it is not moving at the moment because the water flow is pretty low. And this doesn't actually detect really, really low flows like that. So we're not actually going to get any flow from this measurement. This sensor here senses light. And so we put that in the quadrat and obviously try not to put our shadows over it. And then these ones here, this measures the pH and the temperature. And this one measures the dissolved oxygen in the water. When we do these measurements, you actually have to have the dissolved oxygen probe in the water for quite a while because it takes a while for it to adjust to the temperature in the water. And it measures the amount of water, the amount of oxygen in the water is temperature dependent, so it has to kind of recalibrate itself according to the temperature. So it won't give you an accurate oxygen level until it's kind of had some time to adjust to the temperature. So once it's had a few minutes, usually I give it about 15 minutes to adjust to the temperature for the first reading, and then I try and keep it in the water as long as I can while we're measuring, so we don't have to give it that adjustment period. So the first measurement, you have to give it a longer adjustment. Once everything is up and ready, then we use the LabQuest 2, where everything is hooked into that, to record all those readings. This also has a GPS unit in it, so it will also give us latitude and longitude coordinates for our location here. So, and then I also have it takes a 10-second, you can set it to take a 10-second average. So we will take a 10-second average reading, which I won't do at this moment, but that's what we do when we're doing these measurements. So all of this equipment, you can see there's a lot of wires. It's not all fully waterproof. It's a little tricky, but it gives us a lot of information on the environmental variables around our particular quadrat. To measure turbidity and conductivity of the water, we take a small sample of water from each microhabitat in each quadrat in each microhabitat using these special little vials. First, you want to make sure that you rinse the vial about 3 times, at least 3 times, to make sure they're nice and clean. And then make sure that the water is running clear, at least any movements that you're doing isn't stirring up turbidity, stirring up sediment in the water that would affect the turbidity. You want the actual turbidity readings, which is just the normal running water. So when you're ready to take a turbidity a sample, you can place the vial in the water so that it fills up entirely. And then we take the sample back into the lab to measure the turbidity and conductivity there.